Okay. Hi, Manoj. Good afternoon.
Hello, Dasari. Good afternoon.
Yeah.
How are you?
Yeah, I'm good. How are you? Thanks for asking.
Yeah, I am well. Yeah, you are.
Okay. Shall we begin the interview?
Yeah, you are from the SAC background, right? SAC background. Can you
Yes, yes.
can you go through your the roles and responsibilities and daily activities? What tools you
Okay.
use?
Yeah, thanks for giving me this opportunity. Myself, Dasar Kiran. I have total 10 plus years of experience in cybersecurity. So I have started working in SOC, Security Operations Center, as analyst in IBM from 2015 March till date. It's like 11 plus years of experience. So starting 6 years, I worked in IBM, then 2 years in Entity Data and UST Global. So when it comes to my technical experience, I have worked on various kinds of security platforms like Azure Sentinel, Splunk, IBM QRadar, Exabeam, these kind of SIM tools. And when it comes to EDR, I have worked on CrowdStrike, Microsoft Defender, Sentinel-1, Carbon Black. These are the endpoint detection response tools that I have hands-on experience. When it comes to phishing analysis, I have used um, Proofpoint, Tap and Trap. 1 second.
Yeah.
So when it comes to email gateway tools, I have worked on Proofpoint, Tap and Trap, Cofense, and also Mimecast tools. And I also did vulnerability assessment scanning tools like Rapid7, Qualys, and Tenable Nessus Professional. So I have worked on various kinds of attacks, cyber attacks like malware attacks, such as ransomware, spyware, Trojan, virus, malicious worms, networking attacks like port scanning, horizontal, vertical, DOS and DDoS, and password attacks, especially brute force, impossible time travel alerts, and password spray attacks, and other Active Directory related attacks such as golden ticket attack, silver ticket attack, pass the hash attack, and these kind of variety attacks I have worked. Apart from that, I also worked on web application attacks like, OWASP, we call it as Open Web Application Top 10 attacks, SQL injection, cross-site scripting, broken access control. Uh, so I also did admin activities where I do log source integration, integrating various kinds of Windows, Linux, firewalls, databases such as Oracle, SQL, and virtual machines, cloud devices including AWS, Azure, and GCP related log sources to various security SIM platforms in Sentinel as well as Splunk and QRadar. I also do use case creations like rule creations for various kinds of attacks, um, both individual log source as well as correlation rules, which includes multiple device logs. Apart from that, I manually evaluate the L1 engineers tickets. If there are any improvements or corrections in terms of their investigation, I will review these ServiceNow tickets or BMC remedy tickets, how they are investigating, what are the areas they need to improve, what logs they need to check for each and every kind of attack. Those things I will review and give one-to-one discussions. I also do upgrade activities for SIM platforms, such as I did in IBM Kiradar, both minor upgrades and major upgrades. I also create various kinds of reports, monthly, quarterly, weekly reports. For example, I send the emails about the users having access to each and every tool. Do I need to remove any users, add any new user accounts? So every month I will send this report through email to the customers so that we can have only genuine users having access to the each and every tool. Apart from that, the number of log sources which are reporting error log sources, number of devices which are needs to be integrated or help required. So these things we will document in the reports and send it. And to keep myself updated about latest cybersecurity attacks, I regularly, follow various kinds of LinkedIn forums, websites such as ThreatPost, Leaping Computers, Cyber Monitor, Hacker School, Hackers News. And I also go and attend various security conferences which are held by Null Security and some individual conferences from various security companies. That's how I keep myself relevant to the latest cybersecurity attacks and stay ahead of hackers. Yeah, this is pretty much about my total 11 years of experience in this domain.
Yeah, yeah, it's great. Sorry, great. Okay, you have worked from Curator or all tools you have experience.
Yes,
So let me go through the questions, our background in that. Uh,
we will go one by one, like
yeah,
same questions, same pattern. Yeah, fine.
let me go through this. Then,
Yes.
first of all, how do you prioritize the incident in console based on what factors like?
So in every SIM tool and EDR tool, that every day we get a lot of alerts. So in every tool, we have this rating system like critical alerts, medium alerts, or high severity, medium severity, low severity. So first, I will prioritize based upon them. I will select critical alerts first. Suppose if there are three different critical alerts, then I will take the CIA triad: confidentiality, integrity, and availability, the three factors of fundamentals of security. Any attacks which are affecting our availability of services, like DDoS attacks, any ransomware attacks, data loss, any user is trying to reboot the machine, or any malware is shutting down the servers. So that is affecting the services, our operations. So I will give first priority. Second priority, I will give it to integrity related attacks like data modification, configuration changes, manipulation of user accounts. Then I will take those alerts. Third priority is for confidentiality related attacks, any brute force attacks, password spray attacks, any unauthorized access to systems. So these are the uh, factors I will take into consideration while assigning the alerts. Yes.
Oh, great, thank you. Yeah, then what do you mean by CA triad? Triad.
CIA triad is basically the three fundamentals. As I said, it's confidentiality, integrity, and availability. So these three attacks, I mean, these three fundamentals will explain, the important factors of cybersecurity. Confidentiality is to keep the data and information or resources from unauthorized access. Only genuine customers, genuine users, employees should be able to access our information, our files, or our databases, any resources for that matter. So protecting the data from unauthorized access is called confidentiality. For that, we use encryption, encoding, these kind of techniques. Integrity means protecting the data from unauthorized modification. So suppose if I saved some files on my server or on my desktop, the data has to be saved. If some changes have been made, that integrity will be failed. So nobody will trust internet. So protecting the data from unauthorized modification or manipulation of data is called integrity. And availability is like whatever the services we are providing, banking services or any bus services or internet services, all the services to customers has to be available 24 by 7, whether it's data or any applications or web services. It should not be interrupted because of XYZ attackers. So that's the reason we always keep a backup of data. Like if attacker delete one portion of data, we have taken backups so that we can replace immediately and continue the business. Similarly, if one server is down, another server will continue and run the business. So protecting these three fundamentals of CIA, confidentiality, integrity, availability, is the responsibility of security engineer. Yes.
Well, what is the difference between encoding, encryption, and hashing?
So encoding is a very old technique which is used to convert a plain text into ciphertext, like unreadable format. Uh, there are examples like base 64, American Standard Code for Information Interchange, which is called ASCII, ASCII. And these are like 40 years back, we used to have these techniques in our processors, in our data communication, because the attackers are advanced and if they understand the coding technique, they can decode the information. So the first fundamental, which is confidential, will be affected because of this older encoding technique. That's why we have replaced this with the encryption, which is a new technique. So in encryption, we have like data will be converted into unreadable format using public and private keys. So examples like we have RSA encryption, advanced encryption standard, AES. So both encoding and encryption are used to protect the first fundamental, that is confidentiality. And coming to hashing, which is used to protect the second fundamental, the integrity of the data. So when you are sending one data from location A to location B, at the sender level, which is location A, it will generate a hash value. And when the data is received at the point B, when we perform the hash test, the hash has to be same. If any small modification was done for the data, then hash value will be modified or it will be changed. That means the data is not sent properly. That data is not received properly. Some data was lost or manipulated by some attackers. So again, we need to send the data back. So encoding and encryption are used for protecting confidentiality. We can encrypt the data and decrypt the data using public and private keys. Hashing is used to protect the second fundamental, which is integrity. Once we create a hash, it should not be reversed. It cannot be changed. It has to be same at both sender and receiver. So that is the difference between hashing and encryption. Okay.
Yeah, you said that encryption. In that, what is the difference between semantic and asemantic encryption?
Symmetric and asymmetric.
Yes, symmetric.
So we have two types of encryption. One is symmetric and second one is asymmetric encryption. In symmetric encryption, both sender and receiver will have one key, that is public key, to exchange information. Like suppose if I'm sending a file, I will zip the file, okay, and I will create a password to unlock the file. And the same, whatever the encryption, the zip file code, I will send it to you through email or through SMS. So with the same key, you will unzip the file. Okay, you will open the file. That is symmetric encryption. Both sender and receiver will have same key. For example, our UPI. So both bank and user will have same 4-digit pin or 6-digit pin to use the transaction, to confirm the transactions, or OTPs that we use for any kind of confirmation, any services that we are using on a daily basis. Coming to asymmetric encryption, which is like a advanced level. So in this case, sender will have only one key for encryption, that is public key, and to unlock the data, to decrypt the data, receiver needs to have two keys, that is public and private. So private key is with the receiver only. He that should not be disclosed or shared anywhere. For example, real time, bank will send monthly statement to every customer. So bank is sender and customers are receivers. So both bank and customers will have same public key. That is like your name, first 4 letters, and your date of birth, month and year. So that is a public key. And private keys, like every customer will have their own individual name or individual, different date of birth or date of month or date of year. If suppose both are same also, the email ID is different. So every user will have unique email ID. That's the reason they will have separate private key. Then they can open the attachment. So this is an example of asymmetric encryption. So in symmetric, both sender and receiver will have single key, that is public key, for encryption and decryption. In asymmetric encryption, sender will have public key for locking, for encoding, encrypting the data. For decryption, receiver needs to have two keys, public and private keys. Example RSA, for asymmetric encryption, RSA tokens. And for symmetric encryption, we have AES, which is advanced encryption standard, and data encryption standard. Okay.
Good. Okay.
Yeah.
And what are the OSI layers, and can you explain them?
So OSI is a very old model, like open system interconnection. So this contains total 7 layers, like application layer, presentation layer, session layer, transport layer, data link layer, network layer, data link layer, and physical layer. So if a data has to be transferred, information has to be transferred between two machines, like client and server, or between two phones, or between two systems or servers, this is the model which will explain clearly. So in physical layer, data will be sent in cables, and in data link layer, we have switches where it will remember the MAC address of your machine. In network layer, it will remember the IP address. We have routers for that. In transport layer, we have TCP and UDP protocols to make a connection between source and destination. And in session layer, data will be divided based on your internet speed, like bandwidth. And in presentation layer, data will be encrypted for protecting the confidentiality. And in application layer, we can see the real-time traffic on our screens, like Zoom application, Chrome application, Edge application. So whatever you see through your eyes on your screens, that is application layer traffic. Yes.
Well, okay. What is the TCP three-way handshake?
So in OSI model, in transport layer, we have this concept called TCP three-way handshake, where to establish the connection between client and server, we have this, for example, let me show for reference purpose, three-way handshake. So this is a client and this is server. So to establish the connection, suppose this is my laptop and this is like, let's say LinkedIn. So I send www.linkedin.com. So I send a synchronization flag, connection flag, and if the server is available at that point of time, like it has to be having internet power and then availability. Like suppose if the server capacity is exceeded, then it cannot respond. So it will respond back with an acknowledgement. Syn means synchronization. Acknowledgement is response. Finally, I will send acknowledgement. Then that's how the connection will be established. So this process is called the TCP three-way handshake. So it is a connection-oriented process where it will make sure the data is sent successfully from source to destination. Real-time examples are like SMTP, mail, whatever the emails we are sending, we will get the acknowledgement sent successfully, or like day-to-day or message communications. Whenever we send a message, if they're online, it will be sent. We can get the response, the message sent successfully. So wherever we need to send the data with reliable communication, that's where we use this TCP protocol, transmission control protocol. Yes.
Yeah, well. Can you mention the name of the data in the physical layer and data link layer, network layer, and transport layer?
So in a physical layer, we call the data as bytes, and in data link layer, we call it as frames, and in transport layer, in the network layer, we call it as packets, and finally in the what do you call transport layer, there are two protocols. One is TCP, another is UDP. So when you use TCP, it's called segments. When you use UDP, you call it as datagrams. So physical layer bits like ones and zeros, frames in data link layer when we add MAC address, packets when we add IP address, which is a router IP, and when we use TCP protocol, it's called segment. When you use UDP as a protocol, you call datagram. So in each layer, we have different name for the data. And in the fifth and sixth and seventh layer, we just call it as data. Okay, bits, frames, packets, and segments. You can call it as SPFB. Okay, SPFB. Somehow you can remember. Next.
Okay, then what is the difference between layer 2 switch and layer 3 switch?
So layer 2 switch is like basically operates in network layer. It will remember only the MAC address of the machine, which is a physical address. And layer 3 switch, some routers will have the capability of performing both MAC address remembering as well as IP address remembering. So that's why we call it as layer 3 switch. So depends upon the manufacturing company like Cisco, Checkpoint. So they provide both switching and router capabilities in a single device. And that's why switch is available in both layer 2 and layer 3. But router cannot work at layer 2. Router only works at layer 3, which is network layer. But switch has the capability to work at layer 2 as well as layer 3 because of the manufacturers. Okay.
Yeah, okay, great. Can you please explain the practical difference between OSI model and TCP/IP model?
Yes, thanks. So OSI model is a theoretical or reference model which contains 7 layers, as you know, like we have application, presentation, session, transport, network, data link, and physical layer. Coming to TCP/IP model, we have only 4 layers. So like first 3 layers will be called as application, like application, presentation, session will be called as application. Transport is same as transport. Network, you can call it as same network, or you can call it as internet layer. First 2 layers, like physical and data link, we'll call it as network access layer. So top 3 and bottom 2 are merged as 2 different layers. Third layer and fourth layer will be as it is. So TCP/IP is a more kind of a practical model, so which we use regularly in our day-to-day communications, documentations, day-to-day work. So as per TCP/IP model, we have physical layer and data layer together as network access layer, and the network layer will be called as internet layer, or same we can call it as network layer only. Transport is transport side. Session layer, presentation layer, and application layer. Top 3 layers will be called as single layer, that is application layer. So OSI is a more of a reference or theoretical model. TCP/IP, transmission control protocol or internet protocol model, is a practical model. So that is about basics of some networking. Next step, can we move to Windows operating system?
Yes.
Okay, let's go to Windows section. Fine.
Yeah. What are Windows event IDs that security analysts come across on daily basis?
Yes, so in Windows operating system, which is the most common used operating system worldwide, like 80% of every company will use Windows as their primary OS. So here, every kind of activity is categorized into 5 logs. So if you go to event viewer, and there you can see this events means actions, like opening a file, powering on the machine, shutting down the machine, opening a document, writing something, closing a document, saving a file, opening a tab, downloading a file, deleting a file. So every action that we perform is called an event in Windows operating system, and every event is assigned with a ID, which is called event code or event ID. Okay. So in Windows, there are total 5 category of logs: application, security, system, setup, and forward events. A, S, 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 F. A, triple S, F. Application, security, system, setup, and forward events. So on a daily basis, we check login success, login failure, where these logs are stored under security. If you see 46, you can come here and find 4624, which is successful login. So you can see that account was successfully logged on. So whenever you open your laptop and enter a correct password, then it will generate 4624, which is successful login. And then we check failed login, which is 4625, and some other event codes like account creation, account deletion. So these kind of things. So these are the Windows event logs. In password attacks, we check, and for malware related, we check for process creation, process deletion. For user added to privileged group, some identity related attacks, we check user creation, user deletion, user account enabling, user account disabling, user added to privileged group, user removed from a privileged group. So these kind of event logs we can check in the application logs or security logs. It's not responding. Yeah, that's about Windows event codes.
Yeah. Good.
Next.
Yeah. How many types of log?
As I said, we have 5 types of Windows logs. I'll show practically. So first we need to go to event viewer. and you will see a window like this. And there on the left hand side, you can see event viewer, local, custom use Windows logs, application and service logs. So if you expand Windows logs, you'll have 5 category: application, security, system, setup, and forward events. In application logs, whatever the applications we are using, like Chrome application, Zoom application, Notepad application, all these related activities we are performing. So those logs will be stored in application logs. And for every activity that we perform, it will assign a level like informational, warning, error. So that will highlight the criticality of the uh, task we have performed or action we have performed. So I just want to give clarity. Event means action. Log means collection of the data at what time the action happened, on which system, which user, um, on which machine. So collection of all the details, system name, timestamp, at what time this happened, event code details, and who is the user performed that activity, what is the logging level that this this action can be performed. Like for example, you are going on a bike is a event action, and at what time you are going, who is the person who is riding the bike, and if something happens like any, like he slipped on the road or any kind of some or if they performed any, like robbery or some kind of chain snatching. So the type of action they perform, that will assign the criticality, like whether it's see error or warning or some kind of emergency. So that complete information is called log. Okay, that is the difference between event and log. Okay, so 5 types of logs. Application logs will carry what are the applications, like Chrome application, Zoom application that we install. Security logs will have logins, successful login failures, and other user related activity. System will contain Windows backend files related logs, like your CPU information, backend files, your RAM, storage, disk. If you copy anything, so if you are disabling Wi-Fi or enabling Wi-Fi, so all those backend process related information stores under system logs. When you install any third-party applications on your machine, like for example, I have installed Oracle VirtualBox, Kali Linux. So whatever the extra things which are not coming from the Windows original operating system, which you have added third party. So those things will be come under setup logs, which you have manually set up. And forward events, if you are sending the logs from this machine to another machine, that will be stored. Since this is my personal machine, I am not sending any data to any other machine, so no logs. So these are the types of logs in Windows. Okay, next. Done. You are on mute, I think. Manoj.
Oh, sorry, sir. What is the living of the log binary files? That mean log bin
So
in Windows.
log bin files in Windows are like Windows internal files. So for example, if you go to C drive Windows System 32, or else you can CD means change directory. CD space C / Windows and then System 32. So you'll have a lot of files. These are all Windows files. And then in this dir means show the list of files. And I am looking for, let's say, WMIC, some DLL files. So these are some DLL files which are there in Windows. PowerShell.exe. So if you let them order by sort in alphabetical order. Okay. So in Windows, we have these kind of living of the land binary files like schedule task, certutil, WMIC, Windows script, uh, registered service, run DLL32, Microsoft build, PowerShell execution, bits admin. These are all Windows backend files for different purposes. Suppose schedule task.exe. Exe means executable file. So whenever I want to perform some scheduled activities, like every 24 hours, midnight between 12 o'clock to 12:05, I want to take a backup of my laptop. Like every day, whatever I'm creating new documents, new files, installing new applications, any configuration changes that I made, all those things are taken backup by the schedule task. So you can create a schedule task. So we just need to go to schedule task, task scheduler, and we need to select this create task. So if you create just like alarm, so you can create alarm like for different purpose, like why you want to wake up at that time. So same way you can create a schedule task to take backups, to run any script, so to export any data, to download any data. So schedule task. Similarly, PowerShell is used to perform any activities, like if you want to automate any kind of task. So to check, to interact with your hardware, software, so PowerShell. So these are all Windows binary files, means Windows internal as part of the Windows 8 GB, or so currently current Windows OS file size. So let's say we are using Windows 11. It's between 20 GB to 30 GB. It's a software code. Okay, original installation file is 5 GB. After that, they will keep on add new kind of features. They will update. So in that 20 GB, these are like backend processes, which will do some kind of different kind of activities for taking backups, for performing and interacting with the software, for running scripts. So DLL files will extract data, and if you want to export any data to websites from from your machine, so certutil is the operator. Certutil is the backend file. So living of the land binary files are within the code itself, within the random access memory. Like it is not any hard disk, extra hard disk. It is part of the operating system. Okay, whatever the 5 GB or 10 GB file which we downloaded officially from Microsoft, it is there inside that package. So for different tasks, these are like different kind of backend process. Okay, and attackers, use these or misuse the functionality of these things. Instead of writing the malware code to this hard disk. So let me explain. See, this is this is my total storage. Like we have 512 GB, almost half terabyte. So in that 475 GB, only 30 GB is for my operating system, allocated for operating system. Remaining 400 plus 450 plus GB is for storage, like whatever the files I'm downloading, any new applications I'm installing, any videos or audios or images, everything will be stored in that. That is hard disk. Okay, storage. So remaining 30 GB is internal data, that is operating system data. So these living of the land binaries are part of that 30 GB files. Remaining attacker, what they do, instead of putting the malware into this 400 GB, which is extra for storage, they directly put the malware into this 30 GB. What is the advantage? Our EDR agents like Defender, EDR Defender, Microsoft Defender or CrowdStrike, these agents think, okay, this file is coming from that 30 GB Windows software code, which is genuine. Okay, if the file is coming from that extra 400 GB storage, then it won't, the EDR will block it. Okay, so that is called fileless malware attack. So they are not using any extra storage from the hard disk. They are using data from 30 GB. Understood, right? What I'm saying? So that is called fileless malware attack. So this is continuation. for the previous question. So living up the land and fileless malware attack. So instead of writing the malware into hard disk at 400 GB, they just use the 30 GB script, which is the Windows original software code script, so that EDR won't recognize it and it will install the malware without being blocked. Yes.
Yeah, great. Next one. What is LSAS.exe file and its purpose?
So in Windows, if you check a list of running process. So there is a process called lsas.exe. So local security authority subsystem service. So this is a process which will verify your credentials. Suppose if I lock my system and then again if I want to unlock, I need to enter my password. Okay, and my passwords are stored under SAM directory, like under this folder, SAM, Security Account Manager. So whenever I enter my password on my laptop or on my desktop, anybody, so this backend process, local security authority subsystem service executable file will take my username and password. Here it will go. It will go and check. So total on this machine, we have 5 different user accounts, NetSpace users. So whether my username and my entered password is matching or not. So it will verify with the database. If the password is matching, then it will give like this, like successful login. If my entered password is wrong, then it will give 4625 failed login. That is the LSAS file purpose, to verify the credentials entered by the user with the SAM directory, Security Account Manager. That is lsas.exe file functionality. Okay. Okay, man. Fine. Let me